click. Alright, last time we got our particles to orbit each other, so now let's get some geometry instance to them. But we want specific geometry, namely this moon that I referenced and this Earth that I also referenced in. We want the moon to go to 1 and the Earth to go to 0. So let's select this one's the Earth, then the moon, then the particle, and say instance. We can see right away that both particles are getting the Earth. To fix that, let's give it a custom attribute that will control our object index. So a float per particle attribute called custom index, and we'll refresh our selection real fast. And in the runtime, we can say that if the ID is 0, the position is Earth, so we want the index to be Earth, which is 0, or the first object we selected. And make sure that's spelled right. And for the moon, do the same thing. But this time it will be 1. And we'll edit that. You see it didn't change because we still have to plug it into our instancer attributes. So under instancer in your particle shape, general options, custom index. So now we can see that the moon is orbiting the Earth, but it's inside of it. One quick thing, if this is ever grayed out, it's because your instancer, if you select it, its cycle mode is select to sequential. You want that to be none for this to work. So to get the moon farther out, all we have to do is play with the math of our moon position. Ignore that for now. So our moon needs to go farther away, so we'll say 1.5 times in X and the same in Z, and we'll edit that. So now it's going around the Earth. Now to get Earth to start rotating, we're going to want to add another attribute for rotation, and then we can essentially do the same thing as we did for position, but this time for rotation. So add a new attribute called custom rot to vector. We'll add it, and let's refresh our selection here again. And custom rotation in the runtime. So like before, we'll just write a variable to store it, and then we'll call custom rotation here in the conditional statement. I actually want this to be up here. So vector Earth rot equals, for the X, let's say 13. Y, we want that to change, so time, and we'll multiply by 100 so it goes faster. And Z, we don't need anything to happen in there. So edit that, and then, so if it's Earth, the ID is 0, its position is Earth, its index is Earth, and its rotation, which is up here, we can paste that down here. Select this, and that equals Earth rotation. And before, like index, we'll have to plug it in our instancer up here, rotation type to custom rotation. Now if I select the instancer, we can see the wireframe. And if I go through slowly, you can watch it. There's Africa going by. So if you hit play, it's looking pretty cool, but our planet kind of wobbles. The axis should kind of stay in one direction. So to fix that, if you select your instancer and go to this rotation order, make sure you have something that's Y first. And that way, your planet will behave a little bit better. So, if you notice when they're born too, they are born wherever that emitter is, and then they jump to where they're supposed to be. To fix that, in our expression for the particle, we can just select everything in our runtime, copy it, and paste it into the creation. Now, instead of being born at the emitter, they'll be born where they're supposed to be at the first position of their orbit. Alright, cool. So, the last thing I want to show you is just getting a control so you can move this whole system around without having to figure out all the math of where your planets would be. And it's just as simple as adding a locator and then, like we did before, add two vectors together to get our new position. So create a locator, I'll call it space locator. Okay, so what we actually want to do is we'll make a custom vector variable that will hold the information of that space locator. Vector, and we'll call it origin. Spell it right. Equals space loc dot translate x. I'm just going to copy this to make it faster. X, Y, and Z. Oops. Edit that. So now we can say origin is that, Earth's rotation is that, and then let's just do another quick one and call it Earth pause, which equals the origin plus Earth. It's a little bit extra code, but if you ever need to move this whole thing, it's a lot easier than figuring math out later. So, and then we'll want to just make sure we're using the right position of Earth. And in order for the moon to work, we'll have to make sure it's the right attribute as well. So it should behave the same way right now. It does. As soon as we move this locator, we rewind and hit play. Oh, it doesn't even work. What is up with that? Probably because I wrote that in the creation expression, which I did. So if I select all the creation expression, put it in the runtime as well, now it works. See if we move this, even updates on the fly. So a lot easier than figuring out the math of how to get Earth to be here, when you can just set it up at the origin and then move that origin. So in the next spot, I'm going to show you how you can get in the next video, I can show you how you can get some asteroids maybe. like that. Alright, so you can check out my blog for the expressions, and I'll include the scene file for this if you want it as well. So check back for more tutorials. I hope this was helpful.